So let's do another LCT example. This one where the series does not sorry where the series that we want to compare to is not a p series. So here we have the sum from n equals 1 to infinity of 2 to the n over 3 to the n minus 1. Um, you get a sense here. There's a certain intuition in these sorts of problems, and I think this is one of the things that freaks people out is that you have to develop the intuition about what to compare this with. If you think about this, for all that I've talked about how certain terms like constants or lower powers get dwarfed by other terms, look at 2 to the n and 3 to the n. These are very, very powerful functions that grow very, very fast. So it shouldn't surprise you that the most influential thing in the numerator is 2 to the n, and the most influential thing in the denominator is the 3 to the n. So using that intuition, what you can see is that basically, once I discount that sort of pesky constant, this series is basically going to be 2 to the n over 3 to the n, or just 2/3 to the n. So what I'm going to do is I'm going to let an equal this given series, which is, sorry, the given sequence, the general term of the series. I want to be precise about my language. And bn is going to be 2/3 to the n. So let's use the LCT to compare these series. So we calculate the limit as n approaches infinity of an over bn, and that's going to equal the limit as n approaches infinity of 2 to the n over 3 to the n minus 1 times the reciprocal of bn, which is going to be 3 over 2 to the n. So this is an, and this is 1 over bn. So to calculate the limit as n approaches infinity, first of all, we can rewrite this in the form 3 to the n over 2 to the n. So I can multiply everything out. 2 to the n times 3 to the n is 6 to the n. That's just one of the rules of exponents. And on the bottom we have 6 to the n minus 2 to the n. In order to evaluate this limit, I think you probably have a sense of what this is going to end up being. There are a couple of ways you could do this, but I think probably the easiest one is going to be just to multiply by 1 over 6 to the n over 1 over 6 to the n. So that equals the limit as n approaches infinity of 1 over 1 minus 2 to the n over 6 to the n is just 1/3 to the n. It's like 2 over 6 to the n, which is 1/3 to the n. And we learned when we talked about geometric sequences, not series, that if r is between -1 and 1, then the limit of the sequence is 0. So that means that this is 1 over 1 minus 0, which is 1. And of course we can say that 0 is less than 1 is less than L. And we know that the sum of 1/3 to the n, in other words, the sum of bn, which is that, converges. You want to say why it converges. It's a geometric series with r equals 1/3, which is between -1 and 1. And we can say, therefore, the sum of an converges too. And there's our proof of convergence.